Welcome to Metal Training. This is an overview of the X-ray fluorescence, or XRF, technique and sample preparation for XRF analysis. XRF is a powerful measurement technique that can accurately and precisely measure elemental concentrations down to a few parts per million for some elements in solid or liquid samples. However, users should understand the advantages and limitations of these techniques before deciding if this analysis is for you. If you have questions, want to get hands-on training, or are interested in having ASU's metal staff conduct measurements for you, please contact us so we can evaluate your project for suitability. Please note that this short video will give you highlights and won't cover the nuance of sample preparation. Among the important advantages of XRF is that solid samples do not need to be dissolved or digested in acid for analysis, avoiding toxic and dangerous reagents such as nitric, hydrochloric, or hydrofluoric acids. Elements such as silica, carbon, mercury, and osmium that are volatilized during an acid digest for ICP analysis will be preserved for XRF analysis. Analysis is non-destructive, preserving precious or irreplaceable samples. Bulk elemental analysis can measure down to a few ppm over an area a few centimeters across. For samples that are heterogeneous on the millimeter or centimeter scale, XRF analysis may provide a bulk average analysis. Some samples may require little preparation for selected sample types. Even if matrix-matched standards are not available, standardless analysis may still provide valuable information about the relative abundance of elements in different samples. Limitations of XRF include the fact that light elements have higher detection limits, and we typically do not analyze elements as low as carbon. Low atomic mass elements such as sodium or magnesium have much better detection limits under vacuum. Some sample types, such as liquid or delicate solids, may not tolerate vacuum. Matrix-matched standards are essential for accurate concentration analysis. Certified matrix-matched standards are not available for many sample types. X-rays only penetrate to a limited depth in a sample, so if a sample is zoned vertically, this will compromise analysis. Samples that are spatially heterogeneous will provide less reliable data. We require a few grams of material for analysis. Samples and standards should be prepared in identical ways with similar grain size and treatments such as milling and pelleting for accurate measurements. In addition, users need to have training in radiation safety prior to instrument operation. There are 5 main types of sample preparation. In general order of improving data quality, at the low end we have as-is analysis of materials including artifacts of artistic or scientific value that cannot be altered. We have a large volume chamber and the autosampler carousel can be removed and an entire pot, sculpture, piece of metal, or other item can be placed in the chamber. Loose powders is the second type. These can be placed in analysis cups. They cannot be used with vacuum, limiting the light atomic mass elements that can be measured. Liquids can be run, but they cannot be analyzed with vacuum to prevent damage to the X-ray detector. Metal is not currently offering measurement of liquid samples due to previous instrument damage. The next sample prep technique is pressed powder pellets, where you take materials such as rocks or sediments and you ball mill or grind them to a fine and consistent grain size. These are then pressed at high pressure into a solid disc, but they still remain powder. The gold standard technique are fused pellets. These are when you take your material, powder it, mix it with a flux, and melt it at high temperature in a platinum crucible, and then cast it into a glass disc. These glass fused discs are also most likely to have matrix-matched standards available. We have a playlist on the Metal YouTube channel for XRF, including videos on preparing loose powders, preparing pressed powder pellets for XRF analysis, the importance of XRF standards, their characteristics, sources, and how to develop your own custom standards if you can't find certified ones, as well as a training video on how to use our Bruker Puma XRF instrument here at Metal. I will put a link to all those videos in the description for this video. Thanks for watching, and reach out if you have any questions. Please like and subscribe.